In this lesson, we'll compute a derivative using first principles. We will use the limit definition to find the derivative of f of x equals x squared. Step 1. State the function and the definition. Our function is f of x equals x squared. The derivative definition says f prime of x equals the limit as h approaches 0 of the fraction f of x plus h minus f of x, all over h. Step 2. Find f of x plus h and expand. Replace x by x plus h. For our function x squared, f of x plus h equals the quantity x plus h squared. Expanding gives x squared plus 2xh plus h squared. Step 3. Substitute f of x plus h and f of x back into the limit formula. We write f prime of x equals the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared, all over h. Step 4. Simplify the numerator. The x squared and minus x squared cancel. We get the limit as h approaches 0 of 2xh plus h squared over h. Step 5. Factor out h from the numerator. Factor h to get the limit as h approaches 0 of h times the quantity 2x plus h, all over h. Step 6. Cancel the common h factor. Because h is approaching 0, but not equal to 0, we can cancel the h in the numerator with the h in the denominator. This gives the limit as h approaches 0 of 2x plus h. Step 7. Evaluate the limit. Now set h equal to 0 in the expression 2x plus h. We get f prime of x equals 2x. So, using first principles, the derivative of x squared is 2x. Every step follows directly from the definition. Thank you for watching. Tap like, share, and comment, and then follow and subscribe for more quick problem-solving tips. Let's make maths simple, one video at a time, only on muyversemaths.